Okay, dear students, welcome to my class. A special class on IL series halogen derivatives called Halo-Alkanes, Halo-Alenes topic objective questions from IL series by YRK'S Smart Learn Chemistry YouTube channel for all my dearest students. We will discuss about some level 1 questions in this video. Okay, in your material. Let us go ahead with these things to have a discussion on this one. Okay, let us start. So, dear students, what is the first case is we have one more point here in discussion is nomenclature and name of the bond. What is the question? First, we will discuss about the things related to nomenclature of the CX bond. Okay, let us talk about that one. In this, if you see this first question, the general formula of alkyl halides is actually the general formula of alkyl halide. When you just talk about this one, it will be having CnH2n plus 1 X will come. Is the general formula of alkyl halides. Hope you have got a clarity on this one. As if you take the general formula like a chemical formula C2H5Cl ethyl chloride, it matches with this general formula where N if you take is 2, then 2N plus 1 is 5. So C2H5Cl is ethyl chloride or alkyl chloride is the general formula. We have CnH2n plus 1 X. Next thing is the hybridization of carbon atoms in C2H5Cl are. So we have 2 carbon atoms are there in C2H5Cl. If you take these 2 carbons in C2H5Cl, we have all the carbons in this are having the single bonds. So both the carbons are sp3 hybridized. Both the carbons are sp3 hybridized. Third option is the right option for this one. Let us see the third question. The ethyl chloride is what kind of alkyl halide? So when you take the alkyl halide general formula, where halogen attached carbon is linked with one other alkyl group or carbon, then that we will call it as primary alkyl halide. So it's nothing but primary alkyl halide. Next, move to the fourth question. The carbon-chlorine bond in ethyl chloride is formed by overlapping of which one? See, carbon is using sp3 hybridized orbitals and chlorine is having pz orbital. In this, they have a sigma bond is formation is happening. So sp3 and p overlapping, sp3 orbital, p orbital overlapping take place in ethyl chloride carbon-chlorine bond. So second option is the right option for this one. Let's move to fifth question. Question number 4 is finished. Question number 5. IUPAC name of CH3 twice CH, CH2, CH2Br is what? So when you just carefully observe this halogen attached carbon and how many carbons are there? So 1, 2, 3 and the fourth one, whatever is there, on that we have a one methyl group is there. So you can write this one like this. So that means on the first carbon we have a bromine is there. On the third carbon you have a methyl is there. Methyl is there on the third carbon. So that means it's nothing but 1 bromo 3 methyl butane. 1 bromo 3 methyl butane. First option is the right option for this one. Let us see the sixth question. IUPAC name of CH3 and CHBr twice is. So you can skeletal diagram you can write like this. In this, both the halogens are present. Same type of halogens are present on the first carbon. So 1, 1 dibromoethane will be suggested as the right IUPAC name of this compound. Actually, general name is nothing but geminal dibromide. Let us move on to this question number 7. Question number 7, that is N-butyl chloride, isobutyl chloride. What are N-butyl chloride, isobutyl chloride? Means N-butyl chloride carbon is normal. All the 4 carbons are in straight chain. Isobutyl means we will be having 1 carbon branch is there in this one. So these two are said to be chain different. Difference in the chain, they are chain isomers. 8th question, see, with increase in number of halogen atoms and atomic mass of halogen atoms, density of the compound is. Usually what will happen when the halogen atoms number is increasing, atomic mass also increasing about the halogen atoms, obviously what will happen means the density obviously increases for the halogen compounds. 9th question, among the following, density is maximum for which of this one? So it is almost connected with the 8th question we have. More is the number of halogens, more is the molar mass of that one. So we can go with the CCl4 is the right option for this one as the maximum density compound. 10th question, for the same alkyl aryl group, boiling point is more. Usually in the halogens, alkyl group is same. When the halogen is more atomic mass, then that will be considered as the compound which is having more boiling point in such cases. So then the first one, alkyl iodide, is the right answer for this one. So these are the 10 questions we have in CX bond nomenclature related questions are completed. Let us see the next topic that is in this level 1, that is preparation of ethyl chloride. In this one, the following cannot be used. 11th question, if you see, the following cannot be used for the preparation of ethyl chloride from ethyl alcohol. We have PCl3 can be used, PCl5 can be used, SOCl2 can be used. That means sulfuryl chloride SO2Cl2 is not used. So in that case, we have SO2Cl2 is the right option for this question. 12th question. The best reagent for the preparation of pure ethyl chloride is nothing but thionyl chloride, and in the presence of pyridine is best suggested. So which is Darjan's method, the preparation of ethyl chloride. Next, 13th question. If you see, first we have an ethylene is there with HCl. Usually halogen carrier we will use in this case. The halogen carrier is none other than anhydrous AlCl3, which will carry the reaction towards the formation of ethyl chloride. Next, moving into the question number 14, that is ethyl alcohol 3 moles and PCl3. So obviously with 3 moles of ethyl chloride with the formation of phosphorus acid, that is nothing but orthophosphorus acid, H3PO3, the equation. So that means the 14th question we have orthophosphorus acid H3PO3 is the right answer. Again, 15th question is similar to that of Darjan's method. We have same only the presence of pyridine, thionyl chloride gives a pure form of ethyl chloride, sulfur dioxide, and itself. So what is X is nothing but you can consider that is C2H5Cl, and Y you can consider as sulfur dioxide, Z you can consider as hydrochloric acid. So we have first two options are similar as there. So any one you can consider. In this one, there is no right option for that. So the right option is C2H5Cl, comma, SO2, comma, HCl. So nothing is there in these options we have. So we can go with this is the right option for this 15th question. If it is first one or second one, there should be them correction is required in this one. 16th question. What is the name of the following reaction? CH3CH2CH2Br. Sodium iodide in the presence of dry ether. Usually halogen exchange method is Finkelstein reaction. So it is nothing but Finkelstein reaction, iodide formation reaction. 17th question. The reactivity of order of halides for dehydrohalogenation reaction. Usually you all know that dehydrohalogenation reaction and all iodides are the best living groups. So halide, alkyl halide and iodine bond is longer bond. Obviously, it is reactive, then bromide, then chloride, then iodide. So we'll go with the second option as the right option for this 17th question. 18th question, which of the following statements is true in case of alkyl halides? Alkyl halide cases, what is true? Usually alkyl halides are said to be polar in nature due to electronegativity difference between carbon and this halogen. So obviously 18th question, first option is the right option for our discussion. Next, moving on to the properties of ethyl chloride. 19th question we'll see from this properties of ethyl chloride. Ethyl iodide, when heat treated with dry silver oxide, gives not only ethyl chloride, ethyl iodide also they're discussing in this question. Dry silver oxide usually gives diethyl ether in this reaction. That means if you take C2H5I 2 moles, then with silver oxide with dry, if it is moist, you will have ethyl alcohol. If it's dry, then it will be ether. Ether is nothing but C2H5 twice O plus 2 moles of AgI. So that's why diethyl ether is the right answer for this 19th question. Question number 20. Alkyl halides are almost insoluble in water because what is the reason? They are ionic compounds, they have no polarity, they do not form hydrogen bonds with water. Yes, it is correct, because they don't form hydrogen bonds with water, as chlorine is not said to be, iodide is not said to be considered in the hydrogen bonding as because of the size of the halogens. Next, the major product formed when alcoholic AgNO2 reacts with ethyl chloride is nothing but nitroethane. You can refer our NCERT. Nitroethane is the name of the compound. When is silver nitrate, nitrate is treated with alcoholic, silver nitrate treated with ethyl chloride. Next, 22. Ethyl chloride with KNO2. Here we have nitrite, that is ONO, is the right answer for this 22nd question. Next, 23rd question. It's very clear from Friedel-Crafts reaction. Toluene is the product of Friedel-Crafts alkylation reaction, which is our 23rd question. On seeing the question, you can tell directly, is it alkylation or acylation? It is methylation. Methyl is also known as alkyl. So 23rd question, Friedel-Crafts alkylation reaction. Let's move on to 24th question. The chloroethane reacts with X to form diethyl ether. What is X? Usually chloroethane means C2H5Cl. That means ethyl chloride reacts with X to form diethyl ether. Usually Williamson synthesis is giving diethyl ether. So that is with sodium ethoxide, which is the right option for this question. Refer NCERT to get the equation. That is C2H5Cl plus NaOC2H5. That is giving in the presence of dry ether, you will get diethyl ether, that is C2H5 twice O. Next, 25th question. The solvent used in the preparation of Grignard reagent is, usually the Grignard reagent is to be obtained in the presence of dry ether only. Okay, so this is the first option, is the right option for this one. Next, 26th, ethyl chloride does not react with, usually does not react with aqueous AgNO3, but it can react with aqueous KOH and all these things. So 26, second option is the right option, whereas the other things it will react, because sodium and dry ether, potassium cyanide, magnesium and dry ether, all it will react. Only aqueous AgNO3 and the silver ethyl chloride, no reaction. Next, 27. Ethyl chloride reacts with sodium metal in presence of dry ether forms. As you all know, it is one of the reaction, named reaction, top important reaction, that is the Wood's reaction. The Wood reaction is giving straight chain alkanes and alkanes. N-butane is the right answer for this question. 28th question, the reaction sequence. First of all, if you see the KCN reaction with ethyl chloride, ethyl cyanide will be formed. That is nothing but C2H5CN. Usually cyanides undergo hydrolysis, they will give carboxylic acids. That means C2H5 COOH we can consider. In this, we have 3 carbons are there and 6 hydroxygens and 2 oxygens are there. 2 oxygens and 6 hydrogens are there. So C3H6O2 propanoic acid is the right answer for 28th question in this one. Next, 29th question. Ethyl chloride is not used. Actually, ethyl chloride used as anesthesia, local anesthesia, preparation of tetraethyl lead, ethylating agent, but it should not be used as general anesthesia. So 29th one, which is not used as general anesthesia. Next, metal present in Grignard reagent. Yes, we know this is alkyl magnesium halide. Magnesium is the answer for this one. 31st question. When ethyl chloride is reacted with alcoholic KOH, ethylene is formed, double bond is formed. So unsaturated compound is formed, hydrocarbon, which is elimination reaction, dehydrohalogenation. So alcoholic KOH is dehydrohalogenating agent. Beta elimination takes place. That's elimination reaction. 31st question. Let's move on to 32nd question. 32nd question. What is X for in the following reaction? CdH5Cl with X gives us ethyl alcohol and KOH. As if you know, we know that ethyl chloride is giving ethylene in the presence of aqueous KOH. It is giving ethyl alcohol in the presence of aqueous KOH. Ethylene in the presence of alcoholic KOH. So it's one of the substitution reaction with the aqueous KOH forms ethyl alcohol. So aqueous KOH is the right answer for the 32nd question we have. Next, 33rd question. See, alcoholic KOH is there. Obviously, it gives alkene double bonded compound in which the double bonded carbons should be making the stability to the compound by more substituted alkylated groups are there. That means alkene with highly alkylated substitution compounds are there, means they are stable. That means the second one, whatever is there, is more stable because of more substituted one. And as well as the first one is there, which is a minor product, not major product. Okay, so second one is the major product, as well as second one is more stable. The second structure, because highly alkylated alkene, that is one of the important Sedgwick rule related concept we have. But the first one is not following Sedgwick rule. So B and D, where they're present, that is the right option for this question. 33. So we'll go with the fourth option, B and D, for this one. So we have second Roman is a major product. We have second Roman is said to be the more stable because of more substituted compound. Next, we got a chloroform polyhalogen compound, chloroform. 34th question. Let us see. IUP is the name of chloroform. On the same carbon, first only single carbon, we have 3 chlorines are there. As well as that is said to be trichloromethane. That means methane derivative is trichloromethane is nothing but chloroform. 34. Second option is the right option for this one. Let us move on to that question number 35. List 1 and list 2, we have matched the following cases. As we all know, geminine dihalides are nothing but chlorine or halogens are same type of halogen present on same carbon. So C1 is one thing. Vicinal dihalide, that means adjacent carbons, D3. C1, D3. Where do we have? Fourth one is the right option. You can also check with the others. Chloroform is a solvent. Carbon tetrachloride is a solvent. Chloroform is the anesthetic material and all. So A2 means solvent and B4 is nothing but anesthesia. Chloroform is used as general anesthetic. Next, question number 36, we have again match the following. We have Williamson synthesis there in the list 2, and the Williamson synthesis reaction with ethyl chloride and sodium ethoxide. So C1. So C, in all the options we have C1 is there. Then we can go with the Grignard reagent. Grignard reagent is B5 also is there in 1 and 4. Let's move on to the another one. We have a sodium metal and dry ether is said to be used in a Woods reaction. So obviously D2. So D2, C1, B5, D2. C1, B5, D2 is there in the first option. We have first option is the right option. It means that we are finding that A3, what is ethyl chloride? Ethyl chloride is said to be local anesthetic. Let's move to question number 37. That means gave the decreasing boiling points of ortho and para. Usually ortho is greater than para in the case of boiling points. Para is not much equal to meta. So third option is the right option for this question. 38, ethyl chloride sodium hydroxide and AgCN. Usually ethyl chloride with AgCN isocyanate will be formed. So B4 we have ethanolic KOH and ethyl chloride gives C2H4D2. B4D2. B4D2 we have third option is there. That means 38 we have third option is the right option. Rest of the other definitely matches. That means C1. C1 is nothing but C2 H5 Cl reacts with silver nitrate gives nitroethane CH3CH2 NO2. Next, next one more thing, that is nothing but we have observed the question number 38 now. Now it is 39. Dehydrohalogenating agent, as you know, alcoholic KOH. Alcoholic KOH is dehydrohalogenating present in the A4. So A4 itself is the right option for this one. And remaining also can be matched. Dehalogenation, dehalogenating agent is nothing but this is zinc we have. That means B5. Dehydration is concentrated H2SO4, C2. Hydrolysis reaction usually with the case will come with aqueous KOH. So A4, B5, C2, D3 is the right option for this question number 39 you have, dear students. Dear students, let us see the 40 question in your book. That is the shape of chloroform molecule. Shape of chloroform molecule is a distorted tetrahedral because of its 3 chlorine atoms and dipole moment character and all. It is not said to be following a symmetrical geometry according to sp3 hybridization. So that means sp3 hybridization expected is tetrahedral, although because of these 3 chlorine atoms in different planes and all, these are giving distorted tetrahedral geometry to the chloroform. So 41 question is again connected to this hybridization of this one. The 41 we have sp3 hybridization is there in this one. Let's move to the 42. Which of the following is the poisonous gas in the formed when chloroform is exposed to sunlight? That means chloroform when exposed to sunlight, phosgene will be formed. Half mole of O2 in the presence of HNU. Take carbonyl chloride with HCl will be formed. 2 moles of HCl. HCl will be formed. 1 mole of HCl will be formed. So that carbonyl chloride is also known as phosgene. So that means what is phosgene is this carbonyl chloride. So 42, second option is the right option for this question. Let's move on to the optical isomerism. 43rd question. Which of the following is optically active compound? So for optical activity, all the groups around the carbon should be different. To take 2-chlorobutane, so automatically you will get the different groups around it. Ethyl group is one side, hydrogen is one side, chlorine is methyl group is one side, chlorine is one side. 2-chlorobutane satisfies the needs of the optical activity of the compound given in the question. So 43, third option is the right option for this. Next, moving on to 44%, optical isomers which are non-superimposable images usually are known as enantiomers. Next, 45, optically active isomers but not mirror images. They are said to be diastereomers, is a conceptual one. Again, 46, an organic molecule necessarily show optical activity if it contains, that means if it is non-polar, contains, is non-superimposable on its mirror images. Yes, that is the exact statement matches with the definition of the optical activity. Next, 47, a molecule is said to be chiral if it cannot be superimposed on its mirror images. That's what the correct answer for a chirality of a molecule. Next, mechanism of nucleophilic substitution reactions, 48 question. Amongst the following, the most reactive alkyl halide is, as you all know, that iodine is present, obviously that will be highly reactive towards the substitution reactions as it is a good leaving group, iodine. Next, 49. The order of reactivity of alkyl halides depends upon actually nature of alkyl group. It is primary, secondary, tertiary, or halogen, good leaving group base and all we discussed. So nature of both alkyl group and halogen atoms will be considered. Third option is the right option for this 49th question we have. Next, question number 50. The order of reactivity of the following alkyl halides for SN2 reaction. SN2 reaction is favorable for primary, but in this we have all the same alkyl groups given. Again, we will go with the good leaving group concept case where good leaving group is started with this order. So alkyl iodide, bromide, chloride, and fluoride. So fourth option is the right option for 50 question. Question number 51. SN1 reactions occur through the intermediate formation of carbocations. Yes, it forms carbocations, intermediates. That is the right answer for this one. 51 question. First option is the right option we have. 52. The reaction CH3-3CBr is a tertiary butyl bromide with alcohol is forming. It's a substitution reaction. Obviously, it is a substitution reaction. We are now following. Yes, that is the right option. 53. The optical activity active halide allowed to react with Cn minus gives racemic mixture. Halides must likely to be. What kind of halides are giving these type of optical activity? So tertiary alkyl halides are said to be giving this type of valence. Most likely to be they are tertiary alkyl halides with this case. So optically active halide allowed to react with Cn minus gives racemic mixture means they are tertiary alkyl halides. Next, 54. The dextrorotatory optically active alkyl halide undergo hydrolysis by SN2 reaction mechanism. They may be any kind of the process where they may give dextro or they may give lower rotatory substances in the SN2 reaction mechanism. Next, 55 we have. Following is the list of 4 halides. Select correct sequence of decreasing order of the reactivity. So in the 4 Roman numbers, if you see, automatically one thing you can understand that this whatever secondary group is there, that is said to be readily undergoing this SN1 reaction, followed by this another we have bromine. So first Roman and second Roman we have same type of alkyl halides are there, but iodide is good leaving group. We will go with that iodide later, followed by this bromide. Then after we will go with the more stable alkyl halide, which is the benzyl bromide. The benzyl bromide is the least reactive towards SN1. So it is highly stable because of resonance. It undergoes SN2 reaction rather than SN1 reaction. So obviously what happens for the 55th question, we have first option will be right option for this one. Next, 56th question. In the reaction RBr plus Cl minus gives it RCl plus Br. So what is happening here is the replacement of the bromine with chlorine is happening, is a substitution reaction. In this reaction, rate of reaction of ethyl bromide, N-propyl bromide, isobutyl bromide, neopentyl bromide. In what way they are here following this SN2 reaction mechanism? What is the right order of reactivity in these 4 options we have? In such case, what we will think is nothing but usually ethyl bromide is faster than propyl bromide. When the halogen is farther from the last carbon, that means alkyl group is increasing, obviously, and what will happen means the reactivity decreases. So we will go with the second option in that 56th question. 56th question. 57th question. In this reaction, alcoholic AOH is there. Automatically a double bond will be formed. So alkene will be formed as A is alkene, and that undergoes anti-Markovnikov rule gives alkyl halide. Alkyl halide is bromide here in this, that bromide again undergoes Finkelstein reaction. So B to C is a Finkelstein reaction, and A to B is anti-Markovnikov rule. C, obviously it is nothing but primary alkyl iodide, nothing but the first one we have. 58th question. 58th question, if you observe, the order of nucleophilicity of F minus, Cl minus, Br minus, and I minus in the protic solvents is usually what happens when this type of question asked means you will start discussing about the iodine cases only. Iodine is faster in this one. After that, bromide, after that, chloride, and after fluoride, will go with that type of order in this nucleophilic substitution reactions and protic solvents. Next, question number 59. Question number 59 will see, identify the correct order statement of the following from the following. Actually, dichloro methane is used as a solvent. Yes, that is correct. Freons are used refrigeration. Carbon tetrachloride is causing depletion of ozone layer. All are correct in this ABC. Whereas the fourth one, D statement, electrophilic substitution reactions of halobenzene occur faster than those of benzene. No, because Arenes are actually not more reactive than benzene because of deactivating halogen present on the benzene. So A, B, C are the right one. So A, B, C, third option is the right option for this one. So that is the end of haloalkanes. Now we'll see the haloarenes case. 60, question number 60. Fluorobenzene cannot be prepared by direct chlorination. As you all know, fluorine is highly reactive is the right answer for this type of questions. 61. Gattermann reaction, the diazonium group is replaced by X using Y. X and Y are usually Cl minus. That means chloride in these reactions, the chloride should be Cl minus. And another one is copper metal in the presence of HCl. So first one is the right option. It's not Cl plus, it is a Cl minus only. Next, if it is given as Cu to Cl2, then that will be Sandmeyer reaction. So Sandmeyer reaction, Gattermann reaction, we have same products are there, but Gattermann reaction will use copper metal in the presence of HCl to get chlorobenzene. 62 question. Aryl halides are less reactive towards nucleophilic substitution reaction as compared to the alkyl halides. The most important statement is resonance stabilization of aryl halides to give answer for this question. 62. Second statement, which is the right statement, longer carbon halogen bond is not correct one. Inductive effect is not correct one. Formation of less stable carbon ion is not correct one. So resonance stabilization of aryl halides is only the best statement for this question. Next, 63. Towards nucleophilic substitution chlorobenzene. Towards nucleophilic substitution chlorobenzene. Towards nucleophilic substitution chlorobenzene is, what is chlorobenzene? Chlorobenzene is usually less reactive than benzyl chloride as we discussed because of benzyl chloride is resonance stabilized. 64. Aryl halides can be replaced by, can be prepared by, aryl halides can be prepared by Sandmeyer reaction, Gattermann reaction, not from Cradle-Craft reaction. Cradle-Craft reaction is one of the chemical property of this aryl halides. So fourth one, 1 and 3 is the right one. 65. The conditions that are necessary in the preparation of aryl halides from arenes is nothing but actually they are low temperature, absence of sunlight, presence of halogen. All will come under this category we have. So which of the following is the least reactive towards one? In this least reactive, NO2 is there, that is more reactive. And without NO2, you have to check the options. In this again, which is said to be a stronger halogen benzene ring bond is there, that will be the right option for this type of reactions. Least reactive. Most reactive means more NO2 with halogen. Third one. 67, the reaction. So I'm seeing this equation, you can understand there's a inversion of configuration took place. Inversion of configuration usually took place in SN2 reaction only. So 67, second option is the right option. 68, CH2, C2H5Cl converted into A. So moist means ethyl alcohol. It is alcohol. It is nothing but ethyl alcohol. Ethyl alcohol undergoes dehydrogenation, dehydration in the presence of Al2O3 at 360 degrees Celsius. It means it is an alkene double bonded compound, and that forms what type of the product C. The product C is nothing but here we have CH2 double bond CH2 is treated with S2Cl2. S2Cl2. And here what happens, this S2Cl2 is forming mustard gas with this one, that is 68 mustard gas reaction. So that means the double bond will be broken, and this S2Cl2 is joined with that one, forms this mustard gas. Next is 69. Match the list 1 and list 2. List 1 and list 2, select the correct answer given below. There is a Teflon. Teflon is used in non-stick cookwares A3. So A3 we have 1 is there. So obviously remaining all matches. DDT is insecticide, and whatever that freon is there. Freon is ozone layer depletion, D1, all matches with that one. Next, come to the question number 70, we have on sulfonation of C2H5Cl. Now what will happen? Obviously it gives ortho-para derivatives and all. So 70, it is fourth option. 71, it looks, first stage it looks dihydration reaction followed by iodobenzene formation with the liberation of nitrogen gas. Liberation of nitrogen gas is observed in the first option itself. We have 71. First option is the right option. Let's move to 72 question. Chlorobenzene is on fusing with the solid NaOH followed by acidification. Usually it gives phenol. Phenol is the product of this chlorobenzene reaction with NaOH. 73, if you see chlorobenzene reaction with methyl chloride and the presence of AlCl3. So obviously it is Tredelcraft reaction. Tredelcraft reaction products are a mixture of ortho-para chlorotoluenes. Next, 74. Chlorobenzene reacts with magnesium and dry ether, gives a compound. Obviously, it is the Grignard reagent type of compound, phenyl magnesium chloride. Further reacts with ethanol. So, phenyl magnesium chloride is reacts with ethanol, means C2H5OH. The phenyl magnesium chloride is C2H5Mg Cl. So in this MgCl part is positive, C2H5 part is negative. In the C2H5OH, C2H5O is negative, H is plus positive. So this H plus meets with C2H5, forms C6H6. That is the right option for this question. C6H6 is nothing but benzene. 75. The reaction given below is known as. So obviously, on seeing this reaction, we can understand one is phenyl, one is alkyl. Phenyl alkyl is that means toluene. Toluene formation is wood-fatigue reaction. Wood-fatigue reaction. That is 76th question. We have halide most readily hydrolyzes is SN1 reaction is what? Is nothing but tertiary alkyl halide. 77. The correct statement about the electrophilic substitution reaction of benzene is. Usually, benzene halogen is said to be halogen deactivating group in that one. In benzene, moreover, it is a negative inductive effect. It is showing a fourth option is the right option for the 77 we have. Next, 78. Which one of the following is the most reactive in nucleophilic substitution reaction? So, whenever NO2 groups are more, as we discussed, that is trinitrochlorobenzene is said to be the best highly reactive substance towards nucleophilic substitution reactions. Last concept, that is polyhalogen compounds. In polyhalogen compounds, if you observe, there is one question, first question asked, which of the following is used for the metal cleaning, finishing and all? Nothing but is dichloromethane, that is methylene chloride CH2Cl2. It's a conceptual one. First chlorinated insecticide in the lab, that is nothing but DDT we have, diphenyl trichloroethane. Actually, its IUPAC name asked in 81 question, that is 111 trichloro 2, 2 bis 4-chlorophenyl ethane is the right option for that one. 82. The correct formula of freon 1,2 is freon 1,2, whereas the carbon number minus 1 carbon minus 1 is 0. And how many fluorines are there? 1 fluorine is there, and number of fluorines should be 2. In that case, is nothing but we have third option 82, which is the right option. Carbon number and fluorine number, hydrogen number minus 1 always welcome. So freon 1,2 is nothing but this is CF2Cl2. 83. Question number 83. Which one of the following is chloropicrin? Nitrochloroform is called chloropicrin. That is CCl3NO2. Usually, this chloroform CHCl3 is there. Na? That CHCl3 is treated with HNO3. HNO3 can be written as NO2OH. So this H and OH will be removed when we pass the vapors of this nitric acid in the chloroform. You will get CCl3NO2. So third option is the right option for this question. Okay, dear students, I hope you have enjoyed this discussion. And in this, we have discussed all the questions related to the level 1 of our topic, haloalkanes.